Hello, I've had a question about Unit 4, Lesson 5. This is relates Part 2, Question 31. So we have at noon, ship A is 10 kilometers west of ship B. So there we go, A and B, and they're 10 kilometers apart. Ship A is moving 10 kilometers per hour east. So dA by dt, so how fast ship A is going, is 10 kilometers per hour east, and then ship B is heading south, so dB by dt equals 5 kilometers per hour south. So when we extend that out, we do end up with a right angle triangle. So we are going to be using Pythagorean identity here. And they tell us when is the distance between them stop changing. So they are saying when is dH by dt equal to 0 kilometers per hour. All right. So there's our information. If I want to use the Pythagorean identity, I need to do this in terms of time because I'm looking for time. So this is the best way to explain it. So t is my unknown. So before I go into Pythagorean identity, I need to have everything in terms of t. So using a little bit of physics here, this is how it's going to work. So d equals vt. So d is the distance or the length of this side of the right angle triangle. So that means that the distance, let's do it this way. How far does boat A go? So d equals vt. So we know that d will equal 10 times time, but the length of this side of the triangle is going to be 10 kilometers in length minus how far the boat travels. So 10 kilometers minus how far it traveled in that time. On the other axes, dB by dt, so d equals vt, we know that the boat here traveled 5 kilometers in that time. So there are the distances that we are going to use inside of the Pythagorean identity, because Pythagorean identity is measuring lengths of sides of a triangle. So 2h dh by dt equals 2a dA by dt plus 2b dB by dt. The 2's drop out. Oops, and I'm missing an h there. It should be 2h. All right, but we know from the given information that dH by dt is going to be 0. So what that means is that I have 0 equals a dA by dt plus b dB by dt. And my a and b are the lengths of the sides of the triangle at that point in time. So 0 equals, so the length after that amount of time is 10 minus 10t. dA by dt, how fast is the boat traveling, is 10 plus, here's the length of the other side of the triangle, that's 5t multiplied by the b value, or how dB by dt, how fast the boat's traveling. So we end up with 5. So now we have an equation just with t in it, and that's what we're going to solve or isolate for. We're going to divide through by 5, just to reduce my numbers. So 0 equals 20 minus 20t plus 5t. So that means I'll have 15t equals 20. Divide both sides by 15. So t equals 20 divided by 15, or 20 over 15, 4/3. 4/3 of an hour. What's this still? The one thing I've made a bit of a mess up here. Not a huge one. The other thing is that this side of this triangle is decreasing in length. So that means dA by dt should be a negative value. Okay, it should be a negative value because that side's decreasing. So the only thing that really changes is this is going to be a -2 when I substitute it in. All right. which means that I would end up with negative 20 plus 20, which of course, I apologize, changes that. So we end up with 0 equals negative 20 plus 25t, or 20 equals 25t. Divide both sides by 25. And I end up with, that reduces, if you divide top and bottom, 4/5 of an hour. Okay? So what is 4/5 of an hour? If we take 60 minutes, multiply it by 4/5, we end up with 60 times 4/5 equals 48 minutes. So therefore, at 12:48, the distance between them stops changing. Oops, between them stops changing. All right, so if you have any questions with this or any further clarifications required, let me know, and I'll try to help you out.